right, this is a semester final exam review continuation. Number 7. What is the measure of the smallest angle in the figure? So we need to find the missing angles in each triangle. In this triangle at the top, we notice there's a 90-degree angle and an angle measuring 43 degrees. So we're looking for this corner right here. So I know that 43 and 90 would equal 180, right? But a shortcut is I know that 43 and the missing angle will equal 90 because 90 is already a half of 180. So I'm just looking for the other half to equal 90. So I would subtract 43 from 90, and that would give me my missing angle, which is 47 degrees. And then I can do the same thing for the other triangle. I have 90 already, so that's half of 180. The other two angles should represent 90 as well. So I know that x and 52 will give me 90. So subtract 52 from 90, and that would leave me with 28 degrees. So the smallest angle is the angle that I just found, which is 28 degrees. On number 8, they want us to find the value of x. If you notice, x is all the way in that last little corner. So to get to x, I'm going to have to start all the way with 150 and work my way towards that. So the first thing I notice is I can find this angle inside this triangle at the top because 150 and that angle in green form a line or a linear pair. So together 150 and my green angle will be 180 degrees total. So I know that if I have a total 180, that the missing piece, or the small part, would be 30. Okay? Now that leads me to be able to find the missing angle in that triangle, which would be in this corner here. I could find that angle by taking 80 and 30, combining it to get 110, and then take 110 from 180, and that would give me 70. So my blue angle right here is 70 degrees, and it forms a vertical pair with this one down here that is in this second triangle below. Now, there are two ways to get to x. Now, from this position, I'll show you the first way. And it's similar to how we found 70. You would take the blue angle and this 70-degree angle, combine them, so 70 and 70 is 140. And subtract that from 180, which would leave you with 40. So this angle right here is 40. And that angle paired with x form a linear pair, which means they make 180. So if I already have 40, that means x would have to be the missing piece, which is 140. So that's one way to get to x from the blue part that we left off at. The second way you can find x But again, you have to have the blue portion in order to find x first. So this is method 1. The second method you could use involves this remote plus this remote equals the exterior. We talked about this earlier in the year. So R plus R equals E. So that means 70 plus 70 is equal to X, and that's 140 equals X. So method 2 is a shortcut, but again, you could not get to method 2 without finding the blue 70s first. But on your test, here's a big hint. Just use remote plus remote equals exterior, because there's going to be a lot of extra stuff already filled in. The previous angles, the red, the blue, will already be there, so they're distractors. So this is your hint. Only you use the last triangle on the bottom, and those two angles, add them together, and that will give you the missing angle. Remember, those are distractors. Number 9 says, in an isosceles triangle, the measure of a vertex angle is 26 degrees. What are the measures of the base angles? So let's discuss the vocabulary real quick. With your isosceles triangle, you have two congruent sides at least. Opposite those congruent sides will be two congruent angles, which are down here. Those are your base angles. Again, no matter how the triangle is sitting, the base angles will always be the side, or the base angles will always be opposite or across from the congruent sides. And that leaves you with one angle, of course. And that standalone angle is your right here on my picture, and that's called the vertex angle. So in this statement, it tells us how much the vertex angle is. It is 26 degrees. Our job is to find the base angles, so we'll call them x for now. And we know the total sum of all angles of any triangle is 180 degrees. So that means I take my x and my x, which is 2x, plus my 26 degree vertex angle, and I should have 180 degrees. So now I would subtract 26 from both sides, which would leave me with 2x is equal to 154. Divide both sides by 2, and x would equal 77. So each base angle will measure 77 degrees. Number 10 would like for us to write a congruent statement for each pair of triangles below. So when you write a congruent statement, you have to match letter for letter or angle for angle that represents the congruency. So for the first triangle, if I were to start off at the right angle F, and then go to G, and then finally E, notice the path I traveled. I went from right angle down the double side to G, and from G I went down the single side to get to E. So when I come to the other triangle, I have to start at the right angle again, which is K. Hold on, let me put my triangle symbol. So I'm starting at angle K, and then from K I have to move down the double side, which would take me to L, and then from L it would end up at J. So that's the congruency statement. For the next one, I'm going to start at angle B, just because I see it first, and go to angle A, and then C. So if you notice, angle B has two arcs. And then I went from double to single to triple. So when I look at my other triangle, I need to make sure I do that same pattern. So B was the double arc on the bottom triangle. So when I look at the top triangle, C has the double arc. And then I went to single arc, which is D, and then ended up at the triple arc, which is B. So again, you have to match it up letter for letter. It is so important that you do it that way. Can't stress that enough. Number 11, what postulate or theorem proves the triangles are congruent? If the triangles are not congruent, write not congruent. So this is where we have to use one of the big five. Your options are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Those are your five options. If the two triangles do not meet one of those five, you have to write not congruent. So when I look at the first set of triangles, you have triangle NPL and MPL. Since both triangles share PL, that side, it is congruent automatically. So if I look at NPL, go down the single angle, single side, there's an included angle, and then another congruent side. So that means side, angle, side. So it is side, angle, side. Because starting at N, I went down a side that was congruent. The right angle was included in between the second congruent side. All right, on the next set, K is a pair of vertical angles to both triangles. So let's definitely get those marked on our picture. And we're going to do double arcs since the single arc is already taken. Now, if I look at NJK by itself, I have angle N, angle K, so angle, angle, and then I have side. So it is angle, angle, side. Again, I'll highlight it for you. We have angle, angle, side. And, all right, on this next one, TS is shared by both, so let's mark it with 3, since 1 and 2 are already taken. And when I look at the bottom triangle, all 3 sides are labeled, so automatically that's side, side, side. And the final one, RT is shared by both, so let's label mark it. And looking at the triangles in isolation, if I look at SRT, I have angle S. The side between is not marked, but then I have the side across from it marked, and then I have this angle next to that. So it can be read as side, angle, nope, it's none of them. In order to be angle, angle, side, the angle has to look similar, or the setup needs to look like the second one. You can't have the included side so far away from another angle. I'm sorry. It is angle, angle, side. Yes, it is angle, angle, side. Starting at S, angle, then T, angle, and then side. I'm sorry. Yes, it's angle, angle, side. All right. And number 12, there's a lot going on number 12. First, it tells us that KT, which is this entire side over here, is equal to 24. And then it tells us that AB cuts KT in half. So that means this piece is 12 and this piece is 12. How do I know it cuts it in half? Because of the little tally marks. That means they're congruent. You also know that this is an isosceles triangle because these two sides are congruent. It wants us to find the length of AB, but before we can find the length of AB, we need to know what x is. So we can substitute it into either triangle. Since we know that 6x plus 2 is the same measurement as 7x minus 1, we can set them equal to each other. To find x. So I would first subtract 6x on both sides, which will leave me at 2 is equal to x minus 1. And then I would add 1 to both sides, which would leave me with 3 is x. So now that I know what x is, I can replace it to figure out the sides. So 6 times 3 is 18, plus 2 is 20. 7 times 3 is 21, minus 1 again is 20. So it's the same, which is supposed to be the same. Now what I would do if I were you is pull out the triangle in isolation, so separate it from the rest. So this is A, B, T. And then label the sides. AT, we already said is 12. BT is 20. We have to find AB, which is x, so we can use Pythagorean theorem. When we use Pythagorean theorem, we have A and C, not A and B. So keep that in mind. So that's 12 squared plus x squared is equal to 20 squared. 12 squared is 144, and 20 squared is 400. Then subtract 144 from both sides. Leaves me with x squared is equal to 266, or the 256. I think 256. Let me be sure. Let me pull up the calculator. Yeah, 56. X squared is 256. And now you have to take the square root of both sides to get x by itself. So x is equal to the square root of 256, which is 16. So AB is 16. I'm going to pause right here and come back to resume in just a moment.